Hi, my name is Maria, and with Eleni, Rodo, and Anna Maria, we will introduce you the following presentation concerning acceleration. This lesson defines acceleration, its signs and its units, and provides conceptual, graphical, and quantitative examples. Our objectives are: define and describe acceleration, describe and analyze motion in one dimension using equations for acceleration, and determine acceleration from the slope of the velocity versus time graph. Assessment. First, define and describe accelerated motion. A car changes its velocity from 0 to 20 meters per second in 4.0 seconds. What is its acceleration? A car initially traveling at 25 meters per second comes to a stop in 3.0 seconds. What is its acceleration? An object starts from rest and accelerates at 2.0 meters per second squared for 10 seconds. What is its final velocity? And the motion of a particle along a straight line is depicted in this graph. What is the acceleration of the particle from 7 seconds to 10 seconds? During this presentation, we will use the following physics terms: velocity, acceleration, and rate of change, and the following equation, in which acceleration is the change in velocity divided by change in time. Brainstorm. An accelerating object has a changing velocity. Can you share an example of something accelerating? Let's show you some. A coaster making a turn. A ball rolling uphill. A baseball falling. What is acceleration? Two balls are moving to the right, as you can see on the left side of your screen. Their velocity at each second is shown. Which ball is accelerating and what is its acceleration? Ball 2 is accelerating at plus 2 meters per second, so its acceleration equals to plus 2 meters per second squared. The meaning of acceleration. Acceleration is the rate at which velocity changes. In the following equation, A means acceleration, the numerator means change in velocity, divided by the denominator, which means change in time. Units of acceleration. The units for acceleration are units of speed divided by units of time. The acceleration tells you how many meters per second your velocity changes in each second. So acceleration equals to change in velocity divided by change in time equals to meters per second divided by second equals to meters divided by second squared. These units are usually written as meters per second squared. The meaning of acceleration. The equation defines acceleration as the change in velocity, which means final velocity minus initial velocity, divided by the change in time, that is equal to final time minus initial time. For example, a car is initially at rest. 10 seconds later, it is moving at 30 meters per second. Its acceleration equals to change in velocity divided by change in time equals to final minus initial velocity divided by final minus initial time equals to 30 meters per second minus 0 meters per second divided by 10 seconds equals to 3.0 meters per second squared. Thus, an acceleration of plus 3 meters per second squared means that plus 3.0 meters per second is added to the velocity each second, as you can depict on the following matching.
Understanding the concept. If an object has an acceleration of minus 4 meters per second square, its velocity changes by minus 4 meters per second each second. For example, if it has an initial velocity of plus 8 meters per second and accelerates for 1 second, its final velocity is plus 4 meters per second, as you can see on the following picture. The meaning of acceleration. This chart shows the position and speed of an object moving to the right for 3 consecutive seconds. What's the acceleration of first object? The acceleration is plus 1.5 meters per second square. What's the acceleration of object 2? The acceleration is plus 4 meters per second square. What's the missing velocity? It's plus 14 meters per second. Fill in the missing velocities at each time step. Between 0 and 2 seconds, the acceleration is plus 2 meters per second squared. An acceleration of plus 2 meters per second squared means you add 2 meters per second to this velocity for each second for the first 2 seconds. Between 2 and 3 seconds, the acceleration is 0. An acceleration of 0 meters per second squared means the velocity doesn't not change between 2 seconds and 3 seconds. Between 3 and 6 seconds, the acceleration is minus 3 meters per second squared. An acceleration of minus 3 meters per second squared means you subtract 3 minutes per second from the velocity every second. What is happening to the speed? Positive and negative acceleration can cause speed to increase or decrease depending on the direction of the velocity. Signs of acceleration. Positive acceleration of plus 4 meters per second squared adds plus 4 meters per second of velocity each second. Negative acceleration of minus 4 meters per second squared adds minus 4 meters per second of velocity each second. What is the sign of acceleration in each of these four possible cases? Firstly, speeding up in positive direction will cause positive acceleration. Secondly, slowing down in positive direction will cause negative acceleration. Thirdly, speeding up in negative direction will cause negative acceleration. And finally, slowing down in negative direction will cause positive acceleration.
Test your knowledge. A car is headed west, the negative direction on a long straight road. The driver sees a red light up ahead. It slows to stop. Is the car's acceleration positive or negative? Slowing down in the negative direction is positive acceleration. What does minus 1 meter per second squared mean? It means that the velocity changes by minus meter per second every second. Can you describe two ways that an object could have a negative acceleration? It could slow down in the positive direction, and it could speed up in the negative direction. Acceleration on the velocity v-time graph. 1. A car at a constant speed of 3 meters per second for 3 seconds. What does this look like on the velocity v-time graph? It looks like no acceleration at constant velocity. 2. The car accelerates to 6 meters per second over the next 3 seconds. What does this look like? It looks like positive acceleration at changing velocity. 3. The car continues at 6 meters per second for 3 more seconds. What does this look like? It looks like no acceleration at constant velocity. Acceleration causes the velocity v-time graph to have a non-zero slope. Slope velocity v-time. Slope velocity v-time equals change in velocity divided by change in time equals dv divided by dt equals acceleration. Calculate the acceleration from 3 to 6 seconds. Acceleration equals dv divided by dt equals 6 meters per second minus 3 meters per second divided by 3 seconds equals plus 1 meter per second. Position with time. An object starting from rest accelerates at 1 meter per second squared. Its velocity increases with time, making a linear velocity with time graph. What does the position with time graph look like? as the velocity increases, the slope must change. The graph is curves with lines. Acceleration creates a sloped line on a velocity with time graph. Acceleration creates a curve on a position with time graph. In the first and second graph, acceleration is positive, whereas in the third and fourth graph, acceleration is negative. The position with time graph curves upward from positive acceleration like a smile, whereas the position with time graph curves downward from negative acceleration like a frown.
Understanding acceleration. An acceleration of plus minus 5 miles per hour divided by second means the speed changes to plus minus 5 miles per hour every second. Acceleration is the rate at which velocity changes. Acceleration is the change in speed divided by the change in time. Acceleration is a slope of speed versus time graph. How does segment A relate on the diagram below it? What does mean plus minus 5 miles per hour defined by second? What does the word rate mean in the context of statement B? How do arrows represent the idea of rate of changing velocity? How does the equation represent statement C? Translate the symbols and operation into English. Give numerical examples of changing in velocity divided by a change in time. How does the diagram in D represent the text of statement D? What does the straight triangle represent? What does it mean that the lines of the velocity with time graph in diagram go up then down? How is that reflected in the concept of acceleration? Assessment. Define and describe accelerated motion. Acceleration is the rate of change of velocity. For motion along a line, an object that's accelerating is speeding up or slowing down. A car changes velocity from 0 to 20 meters per second in 4 seconds. What is acceleration? A change of 20 meters per second over 4 seconds, the acceleration of 5 meters per second squared. A car initially traveling at 25 meters per second comes to a stop in 3 seconds. What is its acceleration? A change of minus 25 meters per second over 3 seconds is an acceleration of minus 8.3 meters per second squared. An object starts from a rest of accelerates at 2 meters per second squared for 10 seconds. What's final velocity? The final velocity is 20 meters per second, as you can see below. Assessment. The motion of a particle along a straight line and dependent in this graphic. That's the acceleration of particle from of 7 seconds to 10 seconds. Answer 40 meters per second squared.